In this presentation, you will find all the alkyl halide synthesis we have done. So it's not just free radical reactions, it's actually everything, okay, that we have done as far as alkyl halide synthesis is concerned. So we've made alkyl halides from alkenes, alkynes, and now free radical reactions, but I'm giving it in this chapter because I want you to see the differences between all of these syntheses, the advantage, the disadvantage, or the properties of the product you get, okay? And in case you're wondering why I'm focusing so much on alkyl halides, is because you will see that like you have already seen we used it in substitution reactions and elimination reactions. We're going to use alkyl halides a lot as we go on because they're really very good substrates, okay, for either substitution or elimination or making other products as well, okay? So it's kind of good to know their synthesis in one place. All right. So first from alkenes, the addition reactions that we have done. Now I've tried to write all the things possible for all the reactions. You can write more. You can write the mechanism again if you want to. I have not done that. Okay. So I've just given some markers that I've given before also. So if you do hydrohalogenation on an alkene, you end up getting addition reaction, and this is going to be Markovnikov product. It's really important we write the conditions, which here is none, just HCl, that's all you're adding. If you do halogenation on an alkene like Br2 or Cl2, you will end up getting anti-addition, okay, and you'll form enantiomers. Now, I'm not talking about all enantiomers because here also you're forming an enantiomer, but I'm not talking about formation of enantiomers all the time. So you can look at that, as you do your work, okay? And sometimes, in synthesis, we don't worry so much about enantiomers, although we have to in practicality, but sometimes we don't because I need you to learn the reactions, not so much about get bogged down with enantiomers. But anyhow, okay, now when we do halogenations, you will remember that I've always said to you that we don't do so much of fluorination and iodination, okay? They're very different kind of reactions. So for most of these halogenations, you're going to see chlorine and bromine everywhere. So then, let's do the alkene reactions and addition radical now. Okay, so in case of radical reactions, now this is without radicals, this one is with radicals. And so without radicals, that's the normal alkene, which is also on the previous slide. You have the Markovnikov product, and then with peroxides or under radical conditions, you will find that it is anti-Markovnikov product. So again, you can write peroxides, H nu, for light energy or heat delta, whatever you want to write, it's fine. Then from alkenes, you also have allylic substitution. So here, this is a normal halogenation without any specific conditions. So once you add bromine to a double bond, you get bromination, anti-addition. But when you change the conditions a little bit, now you will get allylic substitution. Okay, so here is another one. And the only reason I've given you this is because I'm using another reagent. So you can either use bromine or you can use NBS. When you use N-bromosuccinimide, you don't have to write the free radical condition because it's understood that you're doing a free radical reaction. Here is from alkynes. Alkynes also, there are two ways you can make alkyl halides, and one is just using HBr. Once you do that, again, remember Markovnikov addition. So one of the carbons will get both the hydrogens and the other one will get these two bromine, which is geminal bromines. And then you can do halogenation of alkynes, which will give you 4 halogens, whether it's chlorine or bromine, it doesn't matter, but you get 4. I don't know what do we do with 4, but anyway, it's a reaction. And then from alkanes, okay, for alkanes, the only thing that'll work is free radical, okay? Alkenes, you can do both free radicals or not, but alkanes, you can only do free radical reactions. And then we talked about the fact that you can either have a selective halogenation or you can have a non-selective halogenation. And why would you want that? I don't know. But If you use bromine, then you are a little bit more selective in your products. But if you use chlorine, it's not all that selective because chlorine is more reactive. So the only time you would use chlorine is, when you want to make only one product, or that one product, um, or it will not give you multiple products, which is very hard to do anyway. So it's much better to go ahead and use bromine instead of using chlorine for your free radical reactions. And then here is how we are going to use free radical reactions or alkyl halides in our synthesis, okay? Because the main thing about learning all of this is to how to use them in synthesis, okay? So how will you carry out the following synthesis from an alkane using what you have learned so far, okay? So you can't do anything else. You only can use whatever you have learned so far. It's kind of like cooking and you only have certain spices given to you. So that's kind of what you're doing here, okay? You only have certain things available. That's what you're going to use to make this alcohol. So I'm going to try and use retrosynthesis here to help you out. Of course, I have more videos for you online also, okay? So make sure you use those as well. This is not the end all. But anyway, because this is an introduction to retrosynthesis, okay, for you. So what we do in retrosynthesis is we go backward, okay? So we know that we can get an alcohol from an alkyl halide, and we know that we can get this alkyl halide from an alkane, okay? Now you can put the reagents as you go or not, okay? That's up to you. So here, we have I have, added the reagents later on. So here a hydroxide SN2 substitution will give us this. And if you do bromination on this alkane, it will give you this. The only thing you have to kind of do here when you do retrosynthesis is kind of you have to think in opposite ways. Because this is the product, okay? This is the reactant. It's not the other way around, okay? So it's a kind of a little bit of turning around in your thinking, okay? So I've given you the forward reaction also, so in case you are getting confused by this, so this is a good one to see in forward. All right, so alkane with peroxides give you alkyl halide, and then the sodium hydroxide or just the hydroxide, substitution reaction. Okay, so that's how it works. Now these reagents are very simple so far. We haven't done anything complicated, and we also haven't done so many functional groups yet. Keeping it simple then, right? So, okay, solving for more synthesis. Again, show how you would carry out the following synthesis, again with using alkane and free radicals. So first one is alcohol and the other one is this ether. In both of them, I have a double bond. What am I starting with? From an alkane. Okay, as soon as I know I'm starting with alkane, I know I have to do a free radical. Okay, somewhere I have to do a free radical. Now, in this case, you can also go forward if you want to, and I can write the forward just like this, okay, and I will explain that to you in a second. So you can write forward or backward as you wish. I've given you backward over here, but you can also do forward, okay? So forward would be alkane, and then you have to get a halide on there. Once you know you have to get a halide, you have to get a double bond on there. Then when you have to get a double bond, after that you have to get an allylic halide on that because that's where this group is. And then we just made this one from the previous slide also is just substitution reaction, okay? So you can go forward also if you want. And again, I have gone backward, okay? But you can, I think in this one you could have gone forward as well, okay? But here are your reagents. Again, I've given them all in opposite direction. So this is what we have. So going from an alkane to an alkyl halide, you would use bromine and peroxide. Then here for elimination, you need a strong base and add the heat on there. Okay, so the heat will tell you that you're doing elimination. Then NBS is going to give you very specifically the allylic bromination, and then of course you have the substitution. Okay. Now B can be actually made from the alcohol. Okay, and this is something that everybody kind of forgets to do. So this is not exactly a free radical reaction, but this is just a synthesis. And in this synthesis, this takes you back to substitution reactions, okay? Because in this case, what we are trying to do is we are trying to make this kind of an ether. So you can see between this and this, the only difference is the ether, okay, from the alcohol. But everything else is the same, which means that somehow I have to get from the alcohol to the ether. So how do I get from an alcohol to an ether? Ether meaning the OET, right? Carbon, oxygen, carbon. So the ET group is what I have to add here. All right. So everybody kind of forgets this. So I ended up, I said, let me just go ahead and add that here. So this OH here has to be converted into a nucleophile. Once you convert this into a nucleophile, then you just need to add a substrate here, okay? Because this is the nucleophile now. So substrate, nucleophile, and then you get an SN2 reaction to give you this, which is an ether. And everybody forgets this is an ether, okay? So what are the reagents you need here is for substitution, you need to have an halide. So because this is ether, sorry, excuse me, this is an ethyl group, so you need an ethyl halide over here. So ethyl bromide, ethyl chloride, either of them would work. And how do you go from an alcohol, from an OH to an O minus? And the best way to do that is to, of course, remove this hydrogen. How do you remove a hydrogen? You remove a hydrogen by adding sodium, okay, to that. Now, we have had this discussion before in substitution reactions on how to make alkoxides, because that's what this is, okay, is making an alkoxide. So if you want, go back and review how to make an alkoxide. So you can either use sodium hydroxide because this is an acid. So you can use sodium hydroxide, but there I think also I had asked you this question, or I think I might have even explained it to you as to why you use sodium versus sodium hydroxide. If I didn't explain it to you, then come and ask me, okay, or email me. Why do you use sodium? Okay, because both of them can be used. Sodium hydroxide, sodium can be used to make the alkoxide. But anyway, so we use free radical reactions in synthesis. So here you can see that I have two free radical steps here, okay? I think that's about it for this. Yeah, so this was mainly about synthesis. Now make sure you go through all the videos that I've given to you on my website also for more synthesis.